I'm going to ask you to write down these two questions, these two functions, and differentiate them. Alright, finished? You pause the video or stop the video. Complete your differentiation. Now, let's see what they turn out to be. Number 1, it says y is equal to e to the x over e to the x minus e to the negative x. Alright, so you have a function of e divided by another function of e. What you could do is use the quotient rule. Alright? You have division of two functions. I mean, a function of x divided by another function of x. Did I say e first time? Alright, so dy by dx equal. So you hold the denominator, hold the bottom first, e to the x minus e to the negative x. Differentiate the top, e to the x, minus, hold the top, e to the x, differentiate the bottom e to the x minus e to the negative x over the bottom squared, e to the x minus e to the negative x squared. Alright? Quotient rule. So what you have? When you differentiate e to the x, you get e to the x. So you have e to the x minus e to the negative x multiplied by e to the x minus. Now, this is e to the x times what? We're going to differentiate each of these inside the bracket. When you differentiate e to the x, you get e to the x. Oh, you're going to minus. What happens when you differentiate e to the negative x? Could be done by substitution, right, of the chain rule, but you're going to find that this becomes negative e to the negative x, right? Suppose, for example, you start with y equal e to the ax. Let u be equal to ax. Then y is equal to e to the u. Then dy by dx is dy by du times du by dx. That's what happened there. Just a reminder. So this is dy by du. Now y is equal to e to the u, so dy by du is just e to the u times the u by dx. U is equal to ax, so when you differentiate u with respect to x, you get a. What you have is a e to the u, which is a e to the ax. See that? Now this here, the e to the negative x is like e to the negative 1 times x. So a times x. So a here will be the same as, in the same position as the negative 1. See that? Just a reminder of the chain rule with that. But once you practice a lot with the chain rule, you'll be able to see it quickly. Alright? And then over, you have e to the x minus e to the negative x squared. What happens here now? You have e to the x times e to the x. So it's e to the 2x, remember the indices, minus e to the x times e to the negative x. It's going to be e to the 0, which is 1, minus e to the x times, and you have e to the x plus e to the negative x over e to the x minus e to the negative x all squared, right? So what happens here now? You could open the bracket and say e to the 2x minus 1 minus e to the x, which is e to the 2x minus e to the x, to the negative x, which is 1 over e to the x minus e to the negative x squared, right? Now e to the x minus e to the negative x, those are gone. Negative 1 minus 1, negative 2 over e to the x minus e to the negative x squared. Alright, so that's what you have there. Alright, let's look at the other question, the other function. F of x equals x squared minus 4 cubed. So f of x equals x squared minus 4 cubed. 3x cubed plus 5x. 3x cubed plus 5x. Now what you have, let me just draw a line here, a border. What you have is a function of x times another function of x. So you could use the chain rule here. Since it says f prime, it says f of x, you write f prime x equal, when you differentiate, you hold this as it is, x squared minus 4 cubed times d by dx of the derivative of 3x cubed plus 5x. In the one before I just put d, right? I could have put d by dx, right, and write it like this, but sometimes I just jump over here. Sometimes I just use d for the derivative, right? Like when you are going to use the integration by parts, you just use d instead of d by dx. D by dx would make the work look more messy and crowded. You just use d. But anyway, you can use d by dx here if you want. So hold this, differentiate this, plus, so you hold the first as it is, differentiate the second one, plus hold the second, 3x cubed plus 5x, differentiate the first, d by dx of x squared minus 4 cubed. Alright? So let's see what happens here. You have x squared minus 4 cubed times, when you differentiate this, you can go into the bracket and differentiate each of them. So this is going to be 3 times multiplied by the power 3x to the 3 minus 1, which is 2, plus when you differentiate 5x you get 5. Alright, that's what you have, plus 3x cubed plus 5x times the derivative with respect to x of x squared minus 4 cubed. Now what is that going to be? Again, you can use the substitution, which is the chain rule. If you say y is equal to x squared minus 4 cubed, and let u be x squared minus 4, then y is equal to u to the power of 3. And then dy by dx, which is the chain rule, would be dy by du times du by dx, right? Which is what? dy by du is going to be, it's this one we're dealing with, 3u squared times, sometimes the time is written as a dot, right, times du by dx, this one now, it would be 2x. So putting back the things, instead of writing u, would be 3 x squared minus 4 to the power of 2 times 2x. So this will be 236x, x squared minus 4 squared, right? The 6x, x squared minus 4 squared. So this is 6x, x squared minus 4 squared. You see that? Alright. So we could simplify this a bit. It's x squared minus 4 cubed times 9x squared plus 5 plus 3x cubed plus 5x times, and then you have 6x, x squared minus 4 squared. Now, if you want, you could do some amount of factorization, but this is the answer, you know. You could kind of clean it up a bit and so on and so forth. You could have x squared minus 4 squared outside the bracket. I have x squared minus 4 times 9x squared plus 5 plus x, and then you have 3x squared plus 5, 6 times this x is multiplied by this one, give you x squared, and then you have, well, there will be no x squared minus 4 here, right? So that's what you would have, something like that. Alright, so that is it for now. See you in the next video.